Welcome everyone. We are discussing continuity. Today I will discuss different kind of discontinuity. So these are board's problem, only basic concept. So look, removal discontinuity. Removal discontinuity. What is the definition? A function fx is said to have a removal discontinuity if fa plus equals to fa minus not equals to fa. So right hand limit equals to left hand limit not equals to functional value. So this is our definition. So consider one simplest problem. So fx equals to x square minus 1 by x minus 1, x not equals to 1 and equals to 4 at x equals to 1. So what is f1 plus? Right hand limit. So limit x tends to 1 plus. 1 plus means not equals to 1. 1 plus fx. So limit x tends to 1 plus x square minus 1 by x minus 1. Now if we factorize, so x minus 1 into x plus 1 by x minus 1. Factorization method. So cancelling x tends to 1, so x minus 1 will be cancelled out. So 1 plus 1 equals to 2. So what is right hand limit? Right hand limit is 2. Now left hand limit f1 minus equals to limit x tends to 1 minus fx. So 1 minus means not equals to 1. So it is again x minus x square minus 1 by x minus 1. So factorize, then exactly same way you are getting x minus 1 x plus 1 by x minus 1. 1 minus x plus 1. Now I am saying repeatedly, x tends to 1 minus means x tends to, we have to put x equals to 1, not minus 1. So this is 1 plus 1 equals to 2. So right hand limit 2, left hand limit 2. Now what is the functional value? f1 equals to 4. So what is the conclusion? f1 plus equals to f1 minus equals to f1 not equals to f1. So fx has removal discontinuity at x equals to 1. fx has removal discontinuity at x equals to 1. So why the name removal? Look, right hand limit equals to left hand limit, not equals to functional value. Look at the problem. If we change this definition, suppose f1 equals to 2, then what will be our problem? f1 plus is 2, f1 minus is 2, and what is f1? f1 equals to 2. Then you are getting fx right hand limit equals to left hand limit equals to functional value. Therefore fx is continuous. So you can make it continuous by changing restriction on specified value. That is why the name removal discontinuity. So look, so if it is not given in greater than less than form, if it is given in x not equals to 1 form, we have already discussed. We have calculated the limiting value only. Why? Look at the reason. Because you get right hand limit equals to left hand limit. That is why for solving problem, I have already discussed in part 1, we calculate limit extends to 1 only. Limit extends to 1 fx. Now, note, so difference of, what is laugh? What is jump of function? Jump of function at x equals to a equals to f a plus minus f a minus. So, difference of right hand limit and left hand limit at the specified point is called jump of the function. If jump of the function, what is the jump of the function? 0. What is jump of the function here? 0. So, if jump of the function is 0, we say limit exists. So, this is removal discontinuity. Now, we consider irremoval discontinuity. Irremoval discontinuity. They are divided into two parts. Discontinuity of first kind. Definition. A function fx is said to have discontinuity of first kind if right hand limit and left hand limit exist. Both exist, but they are not equal. Right hand limit exists, left hand limit exists, but they are not equal. So consider a problem. Fx equals to mod x by x, x not equals to 0, equals to 0, x equals to 0. So you know, we have already discussed this is signum function. So what is RHL? So limit x tends to 0 plus fx. So limit x tends to 0 plus. What is fx? Not equals to 0, mod x by x. Now for not equals to 0, so greater than 0. So mod x is x. So x by x is 1. X by x is 1. So LHL, limit x tends to 0 minus fx. So limit x tends to 0 minus. So not equals to 0. So mod x by x. So for 0 minus, mod x is minus x. So this is minus 1. So look, both right hand limit exist, left hand limit exists, but they are not equal. So RHL exists, LHL exists, but RHL not equals to LHL. So you cannot make it continuous by changing the definition of fx at x equals to 0. That is why it is called irremovable discontinuity. This is irremovable discontinuity of first kind. So you only know the definitions. Then problems will be very, very simple. Next, discontinuity of second kind. If at least one of right hand limit or left hand limit is infinite or does not exist, then it is discontinuity of second type. Now consider an example. fx equals to 1 by x. So add x equals to 0. You look, RHL equals to limit x tends to 0 plus fx. So limit x tends to 0 plus 1 by x. So 1 by very small positive number. So this is infinity. 1 by positive number but very small. Now what is LHL? Limit x tends to 0 minus fx. So limit x tends to 0 minus 1 by x. 1 by very small negative number. So this is minus infinity. So at least one of them is infinity. Infinite. So it is of discontinuity. So fx equals to 1 by x has discontinuity at x equals to 0 of second type. So you have learned what is removal discontinuity, what is irremovable discontinuity. They are classified into two parts: discontinuity of first kind and discontinuity of second kind. Then one more definition: continuity in an interval. So we have discussed continuity at a point. Now continuity in an interval. Continuity in an interval. So suppose this is a comma b, interval, closed interval. So what is definition? Suppose a to b is a closed interval. Function is defined here. So if fx is continuous at all points in the said interval, then we say it is continuous in the interval. So what is definition? A function fx is said to be continuous in AB if it is continuous at all points in the said interval. At all points in the said interval. Now it is not possible to verify continuity at all points in the said interval. We verify the continuity. At the restricted point at which function is given. The restriction. If it is continuous at the given point, we say the function is continuous in the said interval. I will discuss it by taking an example. Now at A, you cannot take left hand side. So what will be the continuity at the end point? So the function fx is said to be continuous at left end point A if fa plus equals to fa. We consider right hand only, and continuous at right end point if fa minus fb minus right end point b if fb minus equals to fb. This is b, not possible to get right hand limit, so this. So if it is continuous at all points in the said interval, we say it is continuous in the closed interval AB. Let us discuss one problem. Let us consider an example to define continuity in an interval. So look, fx equals to x square by 2, 0 to 1, 2x square minus 3x plus 3 by 2, 1 to 2. Verify continuity in the interval 0 to. So look, 0 to 2. An condition is given in 0 to 1 and 1 to 2. So there are many points in between 1 and 2. Many points, infinite number of points. But we verify continuity at the restricted point. So at the point 0, at the point 1 and at the point 2 only. Not at all points. If it is continuous at these points, then we conclude it is continuous in the interval AB. So let us verify continuity at x equals to 1. So what is f1? f1, look this restriction, x square by 2, now functional value is 1. So 1 square by 2, so this is half. Now what is RHL? Limit x tends to 1 plus fx. Limit x tends to 1 plus. For 1 plus, so this is greater than 1. So 2x square minus 3x plus 3 by 2. So 2 into 1 square, 3 into 1 plus 3 by 2. So minus 1 plus 3 by 2. So this is again half. So what is LHL? Limit x tends to 1 minus fx. Limit x tends to 1 minus. For 1 minus, lesser than 1 and equal to 1. So this is x square by 2. So 1 square by 2 equals to half. Less than 1. So fx is this. So we are getting f1 equals to RHL equals to LHL. So fx is continuous at x equals to 1. At the restricted point, it is continuous. Now, no more restriction here, only restriction at the end point. So, end point 2. So, what is f2? F2 is 2x square minus 3x plus 3 by 2. So 2 into 2 square, 3 into 2 plus 3 by 2. 2 into 2 square. So this is 8, 8 minus 6. 8 minus 6, 2 plus 3 by 2. So 7 by 2. 4 plus 3, 7 by 2. Now we have discussed, this one is end point, right end point. So we do not calculate f2 plus. So we calculate f2 minus. So limit x tends to 2 minus fx. So limit x tends to 2 minus. What is 2 minus? 2 minus again is this one. 2x square minus 3x plus 3 by 2. Now put x equals to 2. 3 into 2 plus 3 by 2. So 7 by 2. So what is our conclusion? f2 equals to f2 minus. So fx is continuous at x equals to 2. Right end point 2. So actually no need of verification at the end point. It will be obviously continuous because they will lie in the same restriction. So look it again for 0. So what is f0? f0 is x square by 2. So 0 square by 2 equals to 0. So LHL. So for 0, not LHL, RHL, greater than 0. So f0 plus. Limit x tends to 0 plus. For greater than 0, so this is again greater than 0 but very small amount. Mind it, greater than 0 does not imply that it is nearly equal to 1. So this is 0 square by 2 equals to 0. So f0 equals to f0 plus. So fx is continuous at x equals to 0. So what is your final conclusion? Final conclusion, you look. Fx is continuous at x equals to 1 and at the end points x equals to 0 and x equals to 2. Hence, fx is continuous in 0, 2. So, for the interval 0 to 2, so restriction is given at x equals to 1. So, you verify for 1 and n points and conclude. So, restriction, continuity in an interval. So, very simple because you get algebraic function. So, this is not included in our present syllabus also. So, today through this video I have discussed different kind of continuity and continuity in an interval. In the next classes, I will solve problem of competition. Thank you for today.